Hey, all you Gretas and Shutez out there. Welcome to Chapter 5, Section 1, How Do Species Interact? So, let me move me down a little bit. There we go. 5 different ways in which species interact. So we can have intra-specific and inter-specific competition. We can have predation, we can have parasitism, we can have mutualism, and we can have commensalism. And all of these different interactions are going to affect both resource use and population size. So let's go into the details. 1, species have to share limited resources. We don't have just an endless supply of everything. So food, shelter, space are some of the things that species end up competing for. Now you can have intraspecific competition, and this is competition for resources within a single species. So maybe squirrels fighting over a bird feeder. That would be the same species, a squirrel, but they're competing within their own species. Other competitions would be for mates within that species. And then interspecific competition would be competition among different species. So often this will involve one species winning. We've talked about natural selection, becoming more efficient than the others at obtaining whatever the resource is. And so then when two species compete, their niches overlap. So anytime where you have an overlapping area of a niche, that is where that competition is going to happen. So usually critters try to find a way to not compete with each other so they don't have those overlapping niches. So they often do what is called resource partitioning. And this is when competing species evolve specialized traits that allow them to use shared resources at different times, in different ways, or in different places. So the owl that lives in the tree in my backyard will eat the mice at night, and the hawk that lives back there will eat the mice during the day. So they are using same stuff, but they're using it different times of the day, or the different resources, whatever, different places. Like you and your brother shared the same bedroom until you were younger, or until you got older, and then you guys split because you needed your own space. So here is an example. So here are 5 different species of warbler that all live, we'll move me up here. 5 different species of warbler that all live in different parts of the tree. So 5 species, but they all are living in different places. So everybody gets along. Nobody has to compete because they all have their own space. Some species prey on other species, and those are called predators. So individual of one species, the predator, feeds directly on all or part of a living organism as part of a food web. So think lion, tiger, snake, spider. These things are your predators. The prey is the species that is hunted. So the gazelle, the zebra, the bug, the mouse is the prey. One way you can easily separate your predators and your prey are predators tend to have eyes in the front of their head because they're looking towards their prey, and prey tend to have eyes on the side of their head, think bunnies or deer, because they need to be able to get away quickly, so they need to see more. So we have the eyes of a predator. Predator-prey relationships have strong effects on both population size and other factors. Think back to just last chapter when you were looking at the bunny simulation with natural selection. As soon as you brought the wolves in, totally changed everything. So that predator-prey relationship has a huge impact on a lot of how that prey population is going to function. So I don't like myself in the top corner. How do predators capture their prey? So carnivores have tons of methods that they can use to capture the prey. They can run really fast, they can fly, they often work together to hunt. Lionesses will work together to bring down a larger animal. Ambush always works nicely. Camouflage, some of them are lazy and they just kind of hang around until the prey walks right past them and then they'll jump out and grab it. And then chemical weapons, whether that is I'm trying to think of a good one. The vinegar rune will use it to, well, that's more of a defense thing. Any snake bite would be like a chemical weapon. Prey have come up with their own ways to avoid predators. So prey will run or swim or fly very fast. Think about how quickly you can see a mouse run across a room. They often have very highly developed sense of sight or hearing or smell, so they can know when the predators are nearby and get the heck away. Physical protection, like a shell or a spine, Camouflage, sometimes they'll have shapes and colors that help them blend in or look like something else. Chemical defenses, they can be poisonous, they can be irritating, stinging, like stinging nettle. They can be foul smelling or bad tasting. Maybe they're even poisonous. Usually bad tasting means poison of some level. They often have warning coloration, like the poison dart frogs. The other thing they can do is change their behavior. So they can mimic something else, or they can group together to look larger than they are. So here are some really cool examples of prey's defense against predators. So this is called a spanworm, but it also looks like just part of a tree. So it's kind of nifty. This is the wandering leaf insect. So if you were something that ate bugs, you would probably totally walk past this guy. Poison dart frog is going to use that large, bright coloration to tell people, hey guys, I don't taste good. I will poison you. You will die. Leave me alone. This is the viceroy, which mimics the monarch. This is the monarch. Monarchs taste really bad, I've been told. I've never had one. But to birds, they taste really bad. So this guy tastes bad. This guy just looks like he tastes bad. So they survived by looking closely enough like this. The bird is not going to stop and be like, okay, is that a viceroy? Is that a monarch? No, they're just going to not eat them. The bombardier beetle like farts out nasty smelling stuff, which will make people leave it alone. Anytime you fart out nasty smelling stuff, people will tend to leave you alone. The moth, this moth, has large eye spots. So if something was going to eat it, it kind of flaps in the face and it looks like eyes of a much larger animal. So usually in the wild, things aren't going to stop to check. They just go the other way. And then this super guy, and I would highly recommend you guys check out YouTube videos on this because it's pretty cool. But this is a caterpillar that when you touch it, it changes its shape and actually looks like the head of a snake. So if I was a bird and I was going to be like, oh, is this lunch? And I poke it and all of a sudden it looks like a snake, I'm going to get the heck out of there because I don't want to be eaten by the snake. So a phenomenal, really, really cool defense mechanism that this caterpillar evolved to have. So go little caterpillar. So interactions between predators and prey can drive each other's evolution. Once again, think back to the bunnies and the wolves that we did in the simulation in chapter 4. Complex predator-prey relationships play a role in natural selection at both the population level. So predators kill the sick, the weak, the old, the ones that are least fit. So the prey that is better able to survive live to produce more of those offspring, and then they pass on those beneficial traits. You also can have what is called coevolution, and this is when populations of two species interact over a long period of time, and they change. One thing changes, and then the other thing changes. So maybe a flower gets deeper, and then the bird will evolve a longer beak and tongue to be able to get the nectar. Or, I don't know, a flower opens at a certain time, so the bees decide to go out at that certain time. Whether it's a structural thing or a behavioral thing, they work with each other and evolve and benefit each other. So another way that animals can interact is called parasitism. So in parasitism, one species, the parasite, lives in or on another organism and benefits, which is the host, and benefits at the host's expense. So think you can be on or in. So the parasite is going to weaken the host, but it's rarely going to kill them because if you kill your food source, you don't have your food source anymore. So they tend to weaken them, but they try not to kill them outright just because then they've lost their free dinner. So they can live inside the host like a tapeworm. They can attach to the outside of the host like a sea lamprey. You might see those on like sharks. Or mistletoe. Mistletoe is actually a parasitic vine that will actually kill or feed off of a tree and can actually kill it. So the big romantic Christmas mistletoe is actually a parasitic vine, which is poisonous. So not nearly as romantic. And sometimes they can move from host to host. Think something like a tick or a flea can hop from host to host. So visits for a little bit, feeds, and then moves on to somebody else. So parasite is living in or on something else. The parasite is super happy, the host not so happy. Then you have mutualism. When I taught mutualism in my biology class, I would say make two smiley faces. Both species behave in a way that benefits. So they're providing each other with food or shelter, protection, or some other resource. But both parties benefit. So Nemo lives in his anemone. So the Nemo gets protection and the anemone gets clean area because the clownfish eat all the little nasties around them. Birds can ride on the back of large animals and they feed on the pests, so the birds get a meal. Large animals get rid of their nasties. Bacteria live in our intestines, which is actually a good thing. Bacteria get food and shelter in us, and then we get help digesting our food, so it digests in a faster manner than it would otherwise. So it kind of looks like cooperation, but it's not because both parties benefit. It's not just working together and playing nice, it's both parties are getting something out of it. Now you have commensalism, and commensalism is probably the hardest one of these interactions to understand. And this is when one species benefits, but the interaction has little, if any, beneficial or harmful effect on the other species. So I would make one happy face and one like meh face. So somebody benefits, but the other one really could care less. They don't benefit, they're not negatively affected. So air plants, known as epiphytes, will attach themselves to trunks or branches of large trees to access the sunlight. So the epiphytes get access to the sun. Great. The trees could care less. The trees are not bothered. It's not affecting them in any way. So they just don't really care. So that would be an example of commensalism. So if one party in the two is not really affected in any way, but the other one benefits, that would be commensalism. And we have finished the notes. So before I go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.